Good morning, everyone. How are we today? Good? Good? Did everybody not get coffee? Is that why you're so quiet? I know.
They said if you're on the real estate,
You can't get any coffee. Well, we'll try to keep your energy up even though you're not caffeinated. My name's Lisa Scott. I'm a program manager of the Run It Right program at Enbridge Gas Distribution. Thanks for coming to our session today. We're going to be talking about building automation systems and the built environment, improving your facility's energy efficiency. So just an overview today of kind of what we're going to be talking about. Content of BAS facilities, energy efficiency training, Run It Right program training related to BAS systems. We have with us Stephen Dixon, who's a energy management specialist for 35 years. He's one of our main trainers for the Run It Right program. Wave, Stephen. No? We have Shalina Modi with 5 years of energy management experience at the City of Mississauga. She's the energy management coordinator, and she coordinates energy audits at their facilities and manages energy management plans for their facilities. And as well, say hi, Shalini. Yeah. And Jeremy, who's the manager of Region of Peel's energy management team. So they have a $55 million energy budget with over 800 accounts, so he's very busy. So we thank him for coming as well today. Give a wave, Jeremy. Okay. And my name again is Lisa Scott. So just a quick overview about Enbridge Gas Distribution. We are within the GTA. We serve over 2 million customers. So GTA, Barrie, Peterborough, region of Ottawa, Niagara Falls. And we deliver over 12 billion cubic meters of gas annually. So our demand side management programs look at conserving energy within buildings, commercial, industrial, as well as residential. I work on the commercial side of things. Cumulatively, we've been able since 1995 to save 7.8 billion cubic meters of gas, which equals out to 14.9 million tons of CO2. Our DSM program elements include education, energy management, which you'll learn about today, and different energy solutions. We are currently in a process of filing to the Ontario Energy Board. We've submitted our filing. Our guiding principles for the board and for Enbridge this year are programs that focus on behavioral change, energy saving opportunities through a more holistic and collaborative approach, long-term gas savings, and evidence-based customer data. So we haven't received our final okay yet for our programs starting next year, but we will be launching those in January. We'll be improving the incentives that our customers will see. Come on in, guys, find a seat. We'll be improving our incentives that our customers will see from capital projects and improving the process of actually applying for incentives. So our 2020 goals is to reduce by 2020 6.36 billion cubic meters of gas, and we do that through capital improvements, so boiler replacements, energy management programs like Run It Right. So we're looking to reduce 12 million tons of CO2e. So two of the main programs that I work on that we'll kind of talk about a little bit more in detail. One is benchmarking, so our Energy Compass program. So if you have a portfolio of buildings, we will benchmark your facilities against themselves, but we'll also benchmark you against people with buildings that are similar to yours in the same kind of sector. This helps you with your energy planning. We have energy solutions consultants who will meet with you and go over your Energy Compass program, report and review that stuff with you. We also have the Run It Right program, which Stephen will talk a little bit more about, but it's a very simple, easy program to help you implement low-cost, no-cost operational savings within your facility. There is 4 easy steps. You register with your energy service consultant. We send out an investigation agent team to review everything within your building. You then implement your savings and you receive anywhere from $2,500 to $10,000 for completing those low-cost, no-cost operational improvements. And then you monitor. So we actually give you access to an EMIS system, our third-party EMIS system, for 1 year after you've completed your implementation. So very easy, very simple program to participate in, and we've been able to see good savings. Again, we'll talk about that a little bit later. So I'm going to introduce Stephen, and he's going to talk about the context for BAS systems. Good?
Great.
Okay.
Thank you, Lisa. I don't want to get too close to this microphone. It can overpower because normally I'm a lot more active on the stage here. I have to kind of tame it down a little bit. But Lisa, I really like that one slide where you had what you're being asked to do. I think a number of the things, slide 7 there, I'm just going to jump back to that one and just going to reinforce behavioral change. When it comes to building automation systems training, this is one thing that's going to come out as very important. You'll hear that from both of our speakers, and I think it'll weave in amongst what I want to say as well. A holistic approach, looking at the entire building, again, engaging people in the process. Long-term savings. Right? That's essentially going to come out of looking at evidence-based customer data. So using the data that we have already to really ensure that we achieve the results we set out to achieve and we continue to achieve them down the road. That's, in my 35 years of energy management, if I look back at all the initiatives that were in place, and if they were all still working today, this country would probably not be using any energy. And the idea is that sometimes things work, sometimes they don't. Sometimes they work for a while and then they don't work. There's even interactions between systems. You know, a lighting retrofit, what's that going to do to your gas consumption, right? And vice versa. So we have to really look at this thing a lot differently. In 2015, I think it's all about the human side of it. It's about looking at it holistically, and it's also about really using the numbers to the greatest extent possible. I did a session a little while ago with BOMI about big data. Fancy word, but it really says just take the data we all have access to and use it as effectively as possible. The EMIS that you talked about, Lisa, is a great example of that, and we'll take a view of that just before we finish here. In a sense, it's like trending in your BAS for energy. So I'm going to jump now forward to my first slide and just really just set the context here with a couple of slides. For those of you that may have seen me speak before, this slide is probably used in every presentation that I do. 35 years ago, I started off in the technical circle, right? And my job was to do energy audits in buildings. And I would go day after day, week after week to hundreds of buildings and identify opportunities. My job was to find largely technological opportunities, ways that organizations can reduce their energy, their gas consumption in today's context by changing technology. What I started to realize over the years was I was walking by a lot of operational opportunity, a lot of things that simply just taking what we have and making it better. And that's essentially the way to describe recommissioning today. Take what you have and make it operate better and get the reduced consumption accordingly. Now, that's easy to say, a lot tougher to do. And one of the reasons that it's a challenge is because we're not just talking about systems that are absent of people, right? Whether it's the users, the operators, anybody in an organization is somehow influencing the energy consumption of a building through all the different systems that are contained. So when it comes to really changing the way any facility uses its energy, no matter what our approach is going to be, we cannot lose sight of the fact that the human awareness piece is incredibly important. Our habits and better habits, right? Maybe taking really good habits and making them into procedures, and then feedback. Again, coming back to this EMIS piece, looking at the numbers, seeing what the feedback looks like. Are we tracking where we want to be, right? If we're not, do we take action now? Do we wait till the end of the year when it's too late? No, we want to take action as appropriately as possible, as soon as possible. I mean, it's not the only job that we have, but certainly running buildings today is a lot about using energy as well as possible, as good as possible. And then finally, the organizational piece. Again, we're going to talk about technical things today, right? We're going to weave into it the human piece, but ultimately, as soon as you put more than one person in a room, you have an organization, and you have interactions between those. So decision-making, how does decision-making within the organization drive energy management as an operational level? Ultimately, we have to look at this thing, again, from an organizational perspective, holistically as well, not just comprehensively to the energy-consuming systems, but to the organization. I like to think of the thermostat in this room, right, as part of a closed-loop control system for temperature in this room. And if it does its job well, we're comfortable. So, and if it does its job well, we probably use the minimum amount of energy possible, depending on how the systems are set up. That's something we'll talk a little bit more about. Now, closed-loop control for temperature, that thermostat is a sensor. Closed-loop for control for energy in any of your facilities, what are the actuators? What are the sensors? Can we completely control the energy use of a building without people? I'm going to argue that in closed-loop control of an energy in a building, we have to include people in this whole thing. And if we neglect that, I'll show you a slide very shortly, it can create risk, right? It can create risk. People, when engaged, right, and contributing, can actually be a huge asset to any energy initiative. When they're left out of it, they can actually be a risk. So ultimately, at the center of that, there is a dollar sign. And there is essentially both energy, cost, and greenhouse gas emission reductions as well. If we do this thing properly, especially on the gas side today, here in Ontario, right, if we're going to make an impact on our carbon, if that's one of your goals of your organization, we also have to think about natural gas, right, to a large extent, because that's the contributor that each of our facilities has significantly. If you break down your pie chart, we'll go back and do that sometime. Just look at your breakdown of cost, your breakdown of energy, and your breakdown of carbon emissions. You'll find that your carbon emissions lie largely on the gas side, and that's where we can make some huge inroads here. All right, the other piece here is the ground rules. When I talk about monitoring, one thing I always like to suggest to people is they also monitor other things other than energy. Well, first of all, if we're trying to figure out what's driving our energy, we need to monitor those other pieces as well. But if we're looking at outcomes here, we need to make sure that we're not compromising the purposes that our facilities serve. Ultimately, right, if we do energy efficiency properly, energy management properly, energy conservation, whatever you call it, if we do this energy thing properly, we can achieve all the outcomes that are depicted on this slide. We can get those direct energy savings, and maybe through the interactions with the system, within the systems, some of the indirect energy savings too, the sort of the knock-on effects, as it were, right? We can improve comfort. How many people have done a recommissioning activity in a building? How many people have gone through that? Okay? How many people found afterwards that the building was more comfortable? Less complaints, okay? Many of you are saying that, right? I've actually seen organizations do the recommissioning piece solely for the comfort and the service delivery of the building, and the energy became the secondary benefit. Think of that, right? Energy management, well, by sleight of hand, kind of doing something else. Productivity and safety, right, also, right? Those things, that's the purpose for which we use energy, is to create a safe, a productive, a comfortable environment, right? We need to not ever lose sight of that. So whatever we do to reduce energy consumption, right, it cannot compromise this. It has to leave it the same or make it better. And, you know, so when I show a slide later on which says reduce outside air volume, does that mean I want you to starve the building? No. What I want you to do is think about the waste aspect, energy use beyond what we need to use. This slide, that quadrant there, really defines what the need is. And when we think about waste, it's energy use beyond that need. The other thing is systems that use energy properly, efficiently, actually are more reliable typically. There was a term coined a number of years ago called fugitive energy. So the energy that's used inefficiently in a system, wastefully, actually somehow has to go somewhere. Energy can be destructive, and it can destroy things. It can damage things. It can reduce the reliability. So a boiler that's short cycling, that's oversized to a load, it's probably not going to last as long as the one that's appropriately sized to load and cycling properly, and maybe even modulating smoothly against the load. So we have that aspect, that benefit as well. If we're building the business case for any of this stuff, whether it be operational improvements like we're going to talk about today, or capital ones, we have to take these all into account. And then on top of that, we get the greenhouse gas emission reduction and other environmental benefits, depending on the technologies that we're using. So that's kind of the ground rules, right? We need to keep everybody in mind, right? Keep the whole organizational system in mind, and make sure that we're thinking about the way we automate the building and use the automation systems, that we don't compromise. In fact, we look for improvement at every step. This is the story I alluded to a couple of minutes ago. This is a story of an organization in the UK. This was back in the 90s, actually, right? And it's actually written up in a guide called Good Practice Guide 84, Managing Motivating Staff to Save Energy. I'll show you a copy. I'll show you a copy of my email at the last slide. And if you want a copy of this guide and you can't find it on the web, let me know and I can send you one. Basically, it tells the story of one organization with 4 buildings, right? In buildings 1 and 2, which are labeled technology at the bottom there, they implemented a new building automation system. All right? They implemented a new building automation system. Minus 4% savings, that was, oh, wait a second, not a success. That was a failure, right? Terrible. 3% improvement in the second building. Well, I guess one could say that was a bit of a success, but they suspected they could do more. They went to the third building, and rather than implementing the BAS, they simply said, let's see what we can do to engage people. I've actually seen this demonstrated in a recreational facility in the GTA, where the automation system had failed, people were locked out of it, and for a 4-month period, the building operators operated that building manually as best they could, and they were committed to what they were doing. Turns out that building for that 4-month period performed better than many of the buildings that had building automation. So, and that's evidenced here, 16% reduction. When we get to the 4th building, they said, okay, let's engage people, engage the automation, do this properly. That's a 23% reduction. So to me, this is what it's about. Well, I'm not going to promise anybody a 23% reduction, although in some buildings that may be possible. But what I will say is the risk is if we don't involve people, we're going to end up down here in the minus or the marginal pluses. So really, to me, this sets the context for doing this properly. And we're going to get down to talking about the technical stuff in the next few slides. And I'm going to have Shalini and Jeremy come up, and they'll speak about the human element, why they did some of this training. And I think you'll see that human element coming through loud and clear. Okay. So if we were to set about to do some training for an organization today, I might start with a set of learning objectives that looks like this. Right? So to do training to essentially assist people or move people to a better place in how they use the building automation system. I'm not talking about which button to hit and how to move that actuator. I'm talking about when I use that system, what does it do for the energy consumption of the system, right, of the building system itself? I mean, we can all know which buttons to hit and how to sit in our office and change things. And I remember one building automation system that was the first DDC system that I was involved in the eastern part of Canada, going over from a pneumatic system. 3 years later, we went back and looked at the way the building was operating. It was using 26% more energy than it was before the automation was put in. And what we realized was the operator was using the system very effectively to avoid complaints. But they never went out and actually looked at what was happening in that mixing box and what the dampers were actually doing. He was able to meet the requirements of the building and the occupants, but it used a lot more energy to do it. So we need to engage ourselves from end to end in this. So these are the objectives when it comes to integrating energy into BAS training, to identify the importance of the human element, that is the participant in the training, in the facility energy efficiency. And to me, the building operator is the rock star of energy management. They're the people that can really make the difference. To identify building energy consuming systems and the cost of those energy uses, right? Most people don't see cost. They don't see the amount of energy being used when they see a system. They see the system, they can keep it doing what it's supposed to be doing, but what's the cost of that? Like, for example, can somebody tell me, in one of your buildings, right, 1 CFM of outside air on a continuous basis, what's that worth, right, to heat it from outside conditions to inside conditions on average in the year? What's that worth? 1 CFM continuously through the year. How many dollars is that? 1,000? That would be high. I'd like to say it was that high, but it's about between $1 to $2 per CFM per year for heating, just for heating. So your washroom exhaust fan at home that runs 75 CFM, that could be, it could be $150 a year in heat in your house. And then if you add to that the other side of the equation, which is the movement of the air and the cooling potentially of the air, you're going to double that number. So you could be looking all in, gas and electric and movement of the air, close to $3 per CFM per year, maybe even more than that, right? So but people don't see those things, right? So part of BAS training isn't just to say which button to hit and when, it's what's the reason we're doing this and how much impact can I really have? I remember doing a session at the University of Ottawa 20 years ago talking about drives. And the building that we were in and the building operators were in the room, and one gentleman was sitting right up at the back in the amphitheater, and he's a building operator, talking about the use of drives and optimizing ventilation in the building. He came up afterwards, he said, we run those drives fixed. He says, I could take that drive, I could tweak it, I could use it during certain times of the day. I didn't realize just knocking 5% off that during certain times what that was worth. I didn't realize what it was worth. We want to make sure people realize what it's worth, right? To describe the basic components and the actions of the building automation system. I'll show you a slide later on, right, which is a screenshot from a system. How many energy efficiency or energy management functions are represented on that screen? That's an element of good energy efficiency training when it comes to building automation, right? To identify from those screens not just what are the energy consuming or the energy efficiency functions, but what are the abnormal conditions, to be able to see not just the abnormal conditions in terms of, okay, there's a complaint, how can I deal with it, but energy abnormalities, right? What do those look like? Because a lot of times those aren't necessarily apparent. And then also to identify what maybe needs to be done to improve things. So to apply new ways to reduce waste, and I like to focus on waste, right, energy we don't need to use, and efficiency improvement through building control strategies. The 3 S's. How many people have heard of the 3 S's in automation, right? Schedules, sequences, right, and set points. If we can get those right, if we can make a difference in each of those areas, that's huge, right, when you think about it. To identify ways to obtain more effective maintenance, right, using the input from the automation. How can the automation tell us when we need to do maintenance, right? Well, we can buy fancy systems to do this, fault detection and diagnosis, and it'll call out maintenance. But how can the building operator use that automation system to really identify when we need to do some maintenance? Maybe we had some abnormal pressure drops. What's 1 inch of pressure drop from a filter bank or some other obstruction in a system worth in 50,000 CFM of airflow? Now, this isn't a gas-saving one. It's because actually that creates heat. 1 inch of pressure drop in 50,000 CFM is about 16 kilowatts of additional electricity requirement over time, right? That's a lot of money, right? But does that really come out of those building automation screens? No, but an operator trained to see these things can actually find that and act upon it, right? And to establish ongoing activity. So the training itself provides some specific skills, but it creates the dialogue. I know that certainly happened in the training we did with Mississauga, the dialogue between the operators and the energy folks, right? To actually make this part of what we do each and every day, rather than just something that we come to a workshop once a year to do. So establish that ongoing dialogue. That's a tall order, but I think if we're going to be effective at this, that's the way we have to approach it. And you notice the action verbs up there, not just to know, right? It's to apply, to identify, to describe, right? To establish, right? So we want to make sure that people understand what's expected of them and they walk away and we measure the improvement in those skills too, through the training, which is really just good training principles. The HVAC systems, which we're largely talking about here, but not only talking about, but I picked this slide just to, it's called a Sankey diagram, and it shows all the energy flows through a system, both in this case, gas and electricity, or heat and electricity. But as we can see, these systems are complex and they interact. So knowledge of how the systems operate from an energy point of view is very important. Good training will introduce that knowledge and allow the operator to see the energy coursing through the system, not just the things that they're there on a day-to-day basis to manage. Part of being able to see the opportunity. I have a slide in many of my workshops that I do which says energy waste, how to get rid of it in HVAC systems. And really, if you look at the functions, these things listed on the left-hand side here are the functions of any building automation system that really speak to waste reduction. Setback and setup of temperatures, start-stop of equipment, reset on outside air, so reset of heating water temperature or maybe even supply air temperature, right? Optimal set point, so for changing conditions within the space. All we're doing is we're eliminating unnecessary use of energy, or what I call waste. Accurate set point, right? 1 degree C could be 3% of heating energy, right? If we're inaccurate by 1 degree C, right? 3% of heating energy. Those kinds of tidbits of information, I think, stick with people. And they actually, I get feedback that if I think about it that way, I actually start to pay attention to the things that are important. Ventilation on demand, meet the need, in some cases even improve upon what you were doing, but then back off in other times, right? Ventilation on requirement or on demand. And sequencing of boilers against the load, obviously, right? Sequencing of different pieces of equipment. I would normally just say sequencing of equipment, but today, boilers, right, are a key piece, and pumps, heating water pumps, right, would be part of that as well. And there's some good technologies in the trade show around this as well. I noticed that this morning. So, common energy savings functions, a lot about getting rid of waste. Okay, it's kind of hard to see this one, but we'll take a crack at it. I'd like you to try to list off on that, and maybe you can't even read it, you know that they're there, but list off maybe 5 or 6 energy saving functions that screen represents, that their building automation system can offer to an operator. Can you name some of the things that we can do with that to reduce energy consumption in that system? And you're allowed to say the things for gas and electricity. Is that okay, Lisa?
It's totally fine.
That's the collaborative piece, right?
Collaboration, yeah.
Variable speed.
Variable speed, right? So being able to meet a varying demand, okay? And that works on both the electricity and on the heat side of it, okay? What's that? Yeah, the VFDs, yeah.
Pressure drops across filters.
Well, pressure drops across filters, being able to monitor those. So do we have static pressure sensing, right? That's it. Yeah. Yeah, no, that's fine. You can speculate. That's cool. It's just an activity, right? But this is the kind of thing we would do in training. We would put that up there, and do the operators know what features are available in that system to reduce energy, right? Economizers, right? What about economizers, right? Right? What else? Damper positioning, right? And reset of those depending on the conditions of the space. All these schedules down here in temperatures, right? Right? And if a schedule is overridden, is there a feature to override the override? Right? When you think about it, okay, you can have 3 hours, but that's it. After that, it goes back. How many times does that cost you money in your building? Where something is overridden, but then not reset. Even the most diligent operator could forget, especially if they have to dig down. Now, I'm not saying they're at fault and they intended to do anything bad. It's just we forget. I forget, right? It's just, that's just the way we are. So if the system can help us to do that, if I enable the automatic override, I can disable that too, unfortunately, right? Yeah, so there's a whole number of things, right? So push button occupancy status. So a push button in the space to indicate that the system is occupied. We can sense that automatically, but maybe the users would actually do that. So override on heating, start, stop, and systems, right? So there's a whole load of things. I'm not going to go through all that because it is hard to read up here. But encapsulated any one of those views, the building automation system presents a whole host of functions that any good operator can use, right? We need to make sure they're fully aware of what those functions are and the extent to which they can actually reduce energy. What's it worth? What's it worth? Not necessarily in dollars, maybe just as a percentage, but the point is that all of these things have purpose and they have value. Another example here, this was pulled from some other training that we did. You know, here's a system that was operating on a relatively mild day, 23 degrees C, right? All heating valves, right, were 0% open. Well, that means that we're not sending any water to the space, right, or to the zones, right? The return water temperature is very high, right? But we have condensing boilers. Well, at that point, those boilers are not going to condense, okay? All boilers are on, except for one, right? Were the sequences programmed to shut down the last boiler? We certainly could modulate. I expect this system could modulate against an increasing load, bringing on more boilers, sequencing more boilers in. But do we ever take the last boiler offline? Right? Simple one, but that can be a costly one if that's left on there. So again, and then what is the cost of that, right? What is the cost of that condensing boiler? I mean, that becomes a non-condensing boiler, and it's sitting there idling. I mean, we can, depending on its size, that can be a significant amount of gas consumption on a daily basis. We need to make people aware of that. Run It Right program is not a recommissioning program. It operates on a very similar set of principles. There's a plan, there's an investigation, there's an implementation, and there's a monitoring phase. That's just the principles of good recommissioning. Run It Right says, let's just go in and not necessarily do the extensive investigation. Let's do an investigation and see what we can find just to run things a little bit better. Run it right. What was interesting was when we went back and we looked at the measures that were identified by the investigation. I think this was from 2014, Lisa, right? Of the top 95% of measures, so these are the measures by measure count, not by magnitude of energy. If we did it the other way, it would probably be a lot higher. But basically, I think there was 1,100 recommendations, right, or many of which, I would say a high percentage. Any idea what the percentage of implementation is? Like 90%? 90% implementation. So of the 1,100 measures, 1,000 got implemented. Then 95% of those measures, 95% of the measures are these, 20 things? It's kind of like the 20/90 rule. But 60% of all measures recommended had to do with improvement to the way things were being controlled, right? The sequences, the set points, the schedules. That's huge. The Run It Right program is about optimizing the use of automation. It doesn't have to be a DDC system, just any kind of automation in a building. That's huge. If we were to take and put the dollar value on it, which would be rather hard to do, I mean, that would be major. The Run It Right program and the optimization of the use of automation in buildings can have a huge impact on energy consumption. We'll show you some typical numbers in the last couple of slides we'll do at the end. All right, so I'm just going to run through a few of the measures that we found. And again, this would be part of any good building automation system training, right? Tuning a control sequence. Okay, so we got two boilers. We want to make sure that they're sequencing in against the load properly. I've got two nice new condensing boilers in our church, right? And they're both sitting there going back and forth. That's cool. But what if I have a non-condensing boiler and a condensing boiler? How do I sequence that? That gets a little more tricky. And the controls on the new condensing boiler may or may not be able to deal with that. But if I want to use that non-condensing boiler, I better get smart about the way I sequence them. Otherwise, I'm probably going to be using a lot more gas than I need to. So again, sequencing of operation. Add or optimizing the supplier reset schedule. Sorry, supply temperature reset schedule. This would be for heating water circulation in a hydronic system, right? So most heating equipment has a reset curve. Typically, if this is done properly, it can improve or reduce consumption by 4%. And we can measure the results of it. We can plot the gas consumption on the first graph on the left-hand side there versus average outside air temperature on a daily basis. We see a fair bit of scatter. We look at it after we've reset or we've improved the reset control, right? So now we have a much, much tighter correlation, and in fact, the curve is moving downwards. So that's a net reduction. So that's the evidence-based piece that the Run It Right program really brings to the table. We can look at it this way, and we can see the results, like literally in real time, in a sense, through the EMAs that's provided. This kind of graph could be generated by the EMIS system that's available. That's a trend piece that doesn't exist in many building automation systems. I'll speak to that trending thing in a few minutes. Disable equipment when not needed. You know, I don't know what was at the top of your list for recommissioning, but many of them that I see, the number one opportunity is turn it off when it's not needed. Turn it off when not. Turning it down and modulating is a little more difficult. Turn it off when not needed. You know, there's still a lot of waste out there, and we can use our automation to avoid that. Again, not having sequences that are overridden, right, or schedules that are overridden when not required, and then never get set back to the way they should be. Outside air quantity reduction. It could be ventilation on demand with VFDs, but it could also be just simply setting the schedules properly. I once looked at a building from the point of view of its electrical consumption. I could do the same thing today with the EMIS system from Enbridge, right, for gas consumption on an hourly basis, right? I looked at the two buildings. I will tell the story as it was on electricity. The two buildings were two schools. One was a primary school, one was a secondary school. Completely different sized buildings. They had exactly the same profile of electricity consumption. But one had a daycare, one had shops. Why were they the same? Now, they were scaled differently because one used a lot more energy than the other one, right, because of the scale of the building. Out-of-the-box programming for the automation. Nobody had customized the programming to that particular building. Guaranteed that would overventilate one or the other of those buildings, potentially, because that maybe out-of-the-box programming wouldn't work for either one. But it certainly wouldn't work for both, given that they're different buildings with different functions. Upgrading of controls. Maybe we do have some old controls that we can tweak, right? I mean, my favorite one is the little light timer that I have at home, right, for my lights when I go away. It used to be the old rotary thing. Today I can put a digital one in for $8. There's a lot of good stuff out there. I'm not saying we have to invest money. If we wanted to do that, we could, but in new, complete building-wide automation. But you know what? We can tweak bits and pieces within a building and make a big difference with some of the technology that's available today. And if we know just how leveraged that control element is against energy, and the operators will know that too. So part of this isn't us going in and figuring out where we can do this, but working, right, with an organization, right? The building operator, to me, is the eyes and the ears of that building. If I can give them a little bit more energy eyes, right? So looking at it from the energy point of view, they're going to find opportunities that I would never find. You know, it's interesting. A recommissioning investigation is a pretty extensive piece of work. But it's because somebody coming in from the outside actually brings a fresh set of eyes, but also needs to take the time to go through this. Having the building operator there is critical in all of that, right? So again, giving the operator the energy eyes, that's one of the purposes of good building automation system training. Anybody lose their doorstop? That is my favorite. You see that one down the bottom there? That's a damper. And there's a, what's that? Better than a hockey stick, yeah. Well, you could have like a hockey stick, different sizes. I actually once saw a little video on extolling the virtues of building recommissioning, and they actually had the custodian from a school standing there with 3 different wedges next to a panel with a pneumatic control system, and he would use a different wedge for the morning, the afternoon, and start up with the building, right? But that's what we want to try to get beyond. But you know what? Think about that wedge in that damper. I can fix the problem by pulling it out, right? No, I just reinstate the symptoms, right? What's the root cause? How many elements on which element or which component of that system isn't functioning properly, right? And again, being able to use the automation to see that, not just put the wedge in the damper to fix the issue about comfort or not enough air or whatever it is, right? To really get to the root cause. And again, good training for building operators on the energy side can help us to get to the root cause without actually triggering an extensive investigation, just having it happen in real time, in a sense, in the way we operate the buildings. Just bringing the focus on energy, because that is expensive air if we don't need it. Changing set points. Here's a good one. That's a hot water heating system on a ramp. So do we need that on a warm day? No, right? What do we really need to heat that ramp to avoid ice? I mean, we don't like to heat the outdoors, but safety, number one, right? Heat it to the extent that we need to and make sure that the controls are accurate, right? Calibrated. Coming back to the calibration of a thermostat, 3 degrees or 3% per degree C. If that thermostat, right, is taking that space to 1 degree C higher temperature on average, that's about 3% of heating energy controlled by that thermostat. In your house, that's the way it could be for one thermostat. Sensor recalibration, sensor relocation. What if that were warm, moist air coming out of that rectangular exhaust vent there, and that were a sensor which was sensing temperature and or humidity. Do you think our automation system could actually do what it was supposed to do? No, probably not, right? So CO2 sensors, right? They're critical in ventilating a building properly, right? And getting the right amount, not too much, not too little. What's the zone we want our CO2 sensors to be in? Quick question. What's that? The critical zone. There you go. That's a good answer. Well, what is the critical zone? What's the lower end? Somebody once said to me 0. I said, no, to get to 0, you're going to have to ventilate the heck out of that building, right? But what about lower end at 400 part per million, upper end at about 1,000? That we do in the session the other day, and we put the sensor on the table. Everybody was feeling kind of groggy. We were sitting at 1,150, right? We opened the door, which has its own issues, got it down to 600. Everybody livened right up, and it wasn't because I started to speak fast or anything like that. So these things are important both from an energy and an occupant perspective, keeping things in calibration. The more sensors we have, the more work we have to do to calibrate them. That's the unfortunate circumstance, but they're valuable. Returning the VFD to variable speed operation. How many people have walked through a building and seen that hand-off auto switch in hand? It should be called waste off and auto, right? Because that's what's going to happen. Right? I actually saw a VFD the other day going at 90 hertz, 50% over speed. They talked to the people in the building and said, oh, we checked it all out with the motor manufacturer, everything. The fan can do it, but I'm questioning whether that VFD really could do that to that motor. But in any event, you know, do we optimize the use of these things, right? You know, once we get it back to auto, how do we set the schedules under auto? What do we respond to? Do we provide ventilation on demand from the space when an operator decides it? Do we provide a switch, right, as a button where an occupant can indicate occupancy requires ventilation? Can we sense that, right? So how do we actually control that? And how knowledgeable are the operators are? These are the kinds of questions. One of the things you probably are thinking here, we need to do a needs assessment. We need to go back and look at what do our people really know before we go to some energy training. And I think, Jeremy, you're going to speak to that one. You've kind of done that, and Shalini too, right? So, like, what do people really know, right? What do they know? Maybe they know all this stuff, right? Maybe we're underestimating what they're doing now. But we need to know what they really are doing, and we design the training to meet that need, right, wherever that may lie. Static pressure improvements, right? So if we have pneumatics in a building, right, making sure that it's operating properly. I mean, there's nothing wrong with pneumatic systems, but also static pressure sensors, right? This doesn't come down to control elements now, but to the systems, right, themselves. So are those sensors calibrated, right? This can lead to significant overuses of energy. Again, many sensors that we have in these systems today, some of them are a lot more sensitive to calibration issues than others, right? And this is particularly the case for static pressure in air handling systems. Trending features, right? Why are trending features underutilized in systems? Right? I'm going to make the statement that they are, and that's what we hear. Well, one thing I've seen is that there's not enough memory, right? I trend something, I only get a day, right? And I need to trend it for longer. So I don't use it because of that, right? So as we're basically providing facility to these systems, meaning as we're speccing them up, it's important. And I think both Jeremy and Shalene, you're going to talk about the importance of the specifiers, right, and the project managers understanding these systems as well. So making sure that we get the right amount of memory so we can use the trends. When we use the trends, there's an example in a building, right? Essentially, the PID loop was not tuned properly. Through trending, they're able to determine that. Bottom line was they had condensing boilers, high-efficiency boilers that were basically operating within a sequence that wasn't designed for them. They were short cycling. They were operating worse than an atmospheric boiler. You buy the right equipment, but because of not tuning a loop, we don't get anywhere near the performance we expect out of it. Run It Right provides a way to not only, well, your automation system will trend all those functions of the system, but the Run It Right program provides, as you said, Lisa, for a year afterwards, then access to your gas consumption on at the very coarsest 1 day at a time, but it could actually be down to 1 hour depending on the building and the meter that's installed. Looking, I mean, we ran a session last Thursday. This graph on the bottom right here, we scanned through a building. Very quickly, we raised about 5 questions about the way the building was operating. Looking at temperature, looking at gas flow on an hourly or a quarter day or a daily basis. That kind of thing is invaluable. Like, I've been doing electrical profiles for 35 years. This stuff is just as valuable. And you know, you just got to stare at it for a while. You think, oh, that looks like squiggly lines. But once you start to stare at it, once a building operator spends some time with it, knows that building, We did this with the school board. We sat down and showed them their hourly gas consumption. They found 5 out of 10 buildings where the sequencing on the boilers was not set up properly, just from looking at a graph like this, all right? And it may have been set up once, but it may have changed for some reason. We need the tools to be able to capture that. We need the knowledge and the skills of the operators to be able to see these things and then act in some way, either to ask for help or to fix what has to be fixed, depending on the situation. So a very valuable component. So the program starts off with a plan. It sets you up and gets you going. It does the investigation. It supports very generously the implementation, and then it gives you the tool to ensure persistence of whatever reductions are actually achieved, and even to find new things. Because at the end of the day, the operator can go well beyond what the investigators do using a tool like this, looking at it. And you know what? It can also send you an alarm. So you can set up limits, you can set up thresholds, and you can get an email, right?
Yeah, they're set up automatically.
They're set up automatically. You can add your own ones, right? They're set up to be reasonable, to not create nuisances as you would want to do with alarms. But there's a feature. Let's not worry about it until it tells us we need to pay attention to it. That's a good way to use it. So that's sort of the, I guess, the theory piece, right? Because a lot of that is theory. Getting into practice is when we take that and go out and do that kind of training. So there's a couple of municipalities that have done that. We worked with the city of Mississauga most recently in early November, late October, and you're going to hear from Shalini first, and then Jeremy, Region of Peel, are in the planning stages, and we'll be working with them to develop this type of training for their facilities and their operators and specifiers and anybody involved in the facility. They're not just going to stick with operators. They're going to look at everybody involved in the facility. So Shalini, over to you.
Thank you. Thank you, Stephen, and thank you, Lisa. And thank you, everyone, for being here. I'm Shalini Srivastava Modi, Energy Management Coordinator for the City of Mississauga, and here to talk in extension of what Stephen has been talking about, the BAS training. So just to give you a little background about City of Mississauga, we did the first set of dollar to cents trainings done by Stephen and Garth back in 2013. And they were very successful. People received them very well. There were a lot of really valuable energy management concepts that Stephen and Garth shared with everyone, and it was very well done. So we were very happy at that time. Moving forward, since 2014, we have been conducting BAS in-house recommissioning on many of our energy-intensive facilities. And the next slide will show the results that we found, and we kind of sat down and analyzed them, and we tried to see what's going on there. So there were about 11 facilities where we conducted BAS recommissioning, not entire recommissioning, just BAS. And between 11 facilities, all these measures that we found could have the potential of saving $70,000. It's a big amount. And so not all the measures have been implemented yet. We are working towards the implementation. A lot of them have already implemented. We have started to observe savings. Some are on their way. We have to issue POs and whatnot. But this kind of got us thinking what's going on. Yes, we did the training and people are aware, but clearly there's more to be done. And we definitely saw a need of talking about energy. So we have a really robust energy management team at the City of Mississauga. I'm a part of the team. We are 6 of us, full-time employees. We think and dream energy and how to save energy all the time. I think we're very passionate, all of us. But we have some 350 odd facilities to take care of in Mississauga, and how much can 6 individuals do? So I think it's definitely critical to empower our staff throughout and have them think and talk energy and have the same passion that we have, understand why it is so important. So we definitely saw a need of talking more about it, more about energy, and the basic need was to tell them the concepts and the features that are basically used. So we wanted to do something about BAS training, but then I don't think only doing BAS training would have helped as much as we clubbed it with another session of dollar to cents training with with the help of Enbridge, actually, Enbridge and other utilities, but Enbridge was a very big sponsor, and we're very grateful to that. Thank you so much, Lisa, for doing that. And Stephen and Garth, once again, were very happy to come and do the training. So then we started working about, how to do the sessions and how many people to look at, how many staff, and who all to include. So we definitely thought of including the operation staff. As Stephen says, I completely agree, and I believe everyone will agree that they are the rock stars of energy savings and facilities, because they are the eyes and ears, and everything he said just is bang on. I don't need to repeat anything. So operation staff definitely need to be empowered, but we thought of also holding the training for our project managers and coordinators who are responsible for sourcing the BS systems and other systems in the facility, they source and have them installed as well. So there's definitely something that we could share with them and have them understand what their actions mean once they are done and they are done with the facility. The systems are installed, and they'll be installed, and they'll be running for years and decades to come. And what are the challenges that maintenance and operation staff face after that, which could have been avoided if certain things were done a bit differently at that stage. So we split our sessions in 4. We dedicated one session entirely to our project managers and coordinators, and the rest 3 were done for the operation staff. Each and every of the 4 sessions were further divided into 2 parts. The first part was the dollar to cents by NRCan, and the second part was our BS training or BS workshop, developed in-house and delivered by our in-house BS specialists. So the first session, which was the dollar to cents workshop, it was a custom workshop, I would say. Stephen, you would agree with me? So we customized it. They have 6 different types of dollar to cents workshops, and we picked the spot, the energy savings one, and the recommissioning ones. And we customized the workshop with some of the very specific City of Mississauga kind of activities that were incorporated, so that our staff could relate more with it and understand. And we analyzed the latest pilot project of energy dashboard that we have installed in our city hall. Stephen and Garth did the online live analysis of the data on that energy dashboard, and that kind of got people thinking that, oh yeah, this is happening at City Hall, so what could we do and what not. So that was a really good session that they did all 4 days, and it was very, very well received. Again, thanks Enbridge for doing that for us. And I had a quote. Yeah, this is just a quote that I included. Sorry, the slide's a little bit mixed up. It's my fault, maybe. This is Selby Phillip, a professional engineer who works with us. He's an electrical engineer. And he just thought that it was very informative. And sorry, this is, I apologize. I got the things a bit mixed up. But anyway, the session 2 was the BS workshop that was developed and delivered by our in-house staff. The first session was for project managers, as I said, and the objectives as listed are to basically inform them about the BS, what energy efficiency features need to be included in the BS spec, even though we have a standard spec that goes out. Every project is very different, and things have to be tweaked a little bit, but if they don't know what would be required for this particular project, it's kind of hard for them. And sometimes things would slip between the cracks. So to avoid all that, it's best to give them the knowledge and give them the capability to analyze and understand what should go. And also a big part of this training that we did for project managers was commissioning, because commissioning is sometimes not paid, like they don't pay so much attention to commissioning, and that goes a long way. And so we brought in some examples where systems and facilities could have been commissioned better for a lot of things to be avoided. So in the session, we had A lot of very fun and engaging activities. Maybe not so much fun all the time, but engaging definitely. So as a sample I've brought here, there was a commissioning report that was supplied to all the attendees, and they were just, requested to look through it and see what other energy saving feature they could have included to make the facility run a bit better. This is a quote by one of our project managers, and he did say that, a lot of misunderstood features he got a lot of clarification on, and that will help in future.
Actually, Shalini, can I add one thing to that?
Sure.
Because I sat in on those sessions, and the communication piece came out, right? The dialogue and the conversation that had to happen, that really came out, and I think that's what it takes to overcome those misunderstandings at time, too.
Yes. Yeah, there was a lot of question and answer, and that was definitely what you're saying is absolutely correct, Stephen. The second part of the other 3 sessions were for the operations staff. We have 3 approved BS vendors for the city of Mississauga, so there was 1 session for each. And the objectives there was what all can BS really control, and what are the how their simple actions can make a huge difference. Like simple things like what Stephen already mentioned, how much does a simple 1 degree raise cause to the, in terms of dollars, cause to the city. So just to have them think, because they would go around and they would tend to think more for comfort, because they get a lot of complaints throughout the day, and their immediate reaction would be to not get complaints. So they would do things to sort of stop the complaints. But then what is it doing energy-wise, or even the life of the system wise? So those kind of information was shared, and what are the first slide that I showed, like the chart that I showed you, what are the typical measures that we are finding and that can be avoided by their simple daily actions. So those kind of information was shared. Also what they can do to regularly maintain their facility better, so that it not only improves thermal comfort and other kind of comfort for the occupants, but also runs better energy-wise. The operations staff also had a lot of activities. I just brought in an example to share. So we showed them some BS snapshots and then asked them, what do you think is wrong in it? Or for instance, here we just said that you get a complaint about the space being too cold. You go in, open the BS, and this is a screen you see. What are you going to do? So just by the show of hands. So we're just recording their answers. Some would just say, oh yeah, if it's too cold, if I get a complaint, I'll just increase the temperature by 3 degrees. So just to have them think that, do you really need to? Like, you can see the system is already working. It's working to get to the set point. So you just tell the occupant that, we already, the system is working hard to get to the set point, and in another half an hour or so, you should feel better. So it's that behavioral aspect that they understand what's going on, and also are able to communicate with the occupants in that manner, not to just, shut the complaints off. We got a really good round of reviews, positive reviews from our operations staff as well. They learned a lot, and some of them have already started, tweaking the way they operate the system. So they're giving us a lot of feedback regularly, and they have been asking for more training. So we are looking forward to doing another round of these BS trainings in fall of 2016 for those operations staff which could not make it, because sometimes it's hard for them to leave their facilities for multiple reasons. So it has gone really well for us, and we are looking forward to doing more. Thank you so much. And I'll pass it on to Jeremy.
All right. Well, I'd like to thank the panel. They've hit on a number of key points that I was planning on bringing up, but I guess I'll take more of an approach now as just supporting some of what they've said and trying to use some examples of experience of the region appeal that might be good for you guys for lessons learned or opportunities maybe that you might want to pursue yourself. The premise of this presentation, the region has just started down our path with Enbridge to develop the training modules. So we're not quite at the point with this piece as Mississauga was. So I won't have necessary results pertaining to the training, though I can give you examples of how we will be performing that training. That's not to say that the region hasn't been doing training. It's been a little bit more on an ad hoc basis. So we're taking the lessons that we've learned from that experience and are going to put it into the training, which I'll discuss a little bit more today. In addition to that, I'm just going to speak a little bit to why the region is in the business of building automation systems and what the benefit has been to us and where we foresee it in the future. So, and I won't go too much onto this because we have discussed this a bit already in today's presentation, but here some of the benefits to BAS for us is one, the opportunity that it gives our operator staff on maintenance. Making sure that systems are operating efficiently, it affects the wear and tear on our different systems. So we are often trying to optimize that piece. We also use it as a way to do a bit of preventative maintenance. If we see things trending in a negative way, we'll go and look at why that might be happening, and the BAS helps bring that forward. It allows us to do some troubleshooting in advance of bringing in an external vendor to work on it so that we can help hone in on that scope of work. And it also lets us look at things when sometimes it's just competing systems, and we find that our BAS will let us find that out. Like for instance, not all of our systems, unfortunately, and all our facilities are on our BAS. So if we have a electric baseboard heater in an office that could be competing with more of our central forced air system, that can start to become a problem, which will start to trigger the BAS and have that conflict. So through troubleshooting with our system, we can start to find those problems and address them rather than bring in a vendor and spend a lot of money that might not be necessary. And that's actually a key thing on that piece that is worth noting, especially when you're doing it, installing a BAS in more of a retrofit scenario. Oftentimes, staff will assume that the existing building's HVAC system was operating optimally, and everything going forward is now the BAS's fault because it's new, and for some reason they forgot that everything wasn't running perfectly in the past. So you get a lot of calls to, oh, the BAS isn't working, people are complaining about it being cold, people are complaining about it being hot. Even in facilities that don't have such systems, you still have those complaints. That's just going to build on the importance, again, of making sure that the operators are trained, that others in the facility are trained. As many people as you can train on what this system is doing, the better it's going to be for everyone at the end of the day. We also do BAS to save money. It's not just energy conservation. We have found some good results, especially if training happens. We've also seen negative results, as Stephen pointed out, where if training did not occur, we've seen spikes in energy usage because people didn't commission it correctly. You had the default settings put on, and the building was actually operating more poorly than it was prior, so we'd have to address that. We have addressed those kind of issues, but it can happen. The other piece is, and I'll discuss this in a coming slide, is it allows for, and this is also in scheduling, allows for shifting energy use and taking advantage of energy rates and things like that. And we have installed in some of our more sophisticated systems triggers that are based on rates. Comfort's a big piece. It's been discussed. We want to make sure that our staff feel that their working environment is a comfortable, productive work environment. We found when the system's operating effectively and reliably, that is something that can be achieved, and that has a lot to do with the training piece. And another benefit is more the environmental aspect of it. The Region of Peel has some very strong climate change goals that we're trying to reduce greenhouse gas emissions, but we're also, we have public health as part of the region, so air quality is another piece that we've looked into. So we do believe that a well-run BAS will help us hit on a number of these goals. So BAS in practice, so there's some of the obvious things that we use our system for, ensuring that interior temperature set for the comfort piece, ensuring that we're running on appropriate operating hours and ramping up based on schedule. But we've also tied into, like I mentioned earlier, to electricity rates. Well, we spend a lot of money and energy, a lot of it's for pumping water. So if we can figure out ways to take advantage when the electricity rates are low, to pump water to certain spots and then wait and then pump water again to different storage areas and have those triggers tied in to our system from the province, it allows for significant savings for us. And that's we're talking millions. This is a $27 million portfolio. So if we can find even percentage points, it has significant savings and pays us back. But it doesn't have to necessarily be that. You can even tie it if you're just on a time of use type of facility, a smaller energy load. You still can take advantage of pre-cooling and things like that to find those savings. Not to mention also just conserving energy where possible can save you money. On the environmental piece, we've tied our system into smog alerts. So when we do get announcements from, I believe it's the feds, but it might be the province, I'll have to check. It's either Environment Canada or the province, and we're being told that there's a smog alert. We do change our set points. Typically that happens in the summer, so we have an automated response that will let our set points go up a couple degrees, so just to do our part in that. So bridging behavior with technology, we, and Stephen hit on a couple great points, so I won't spend too much time talking about this, but at the region we are trying to, at least within energy and environment, which is my group, we're trying to change the culture a bit. We're trying to move towards more people thinking more about the environment and the way that they consume energy. And we do see that there is a fit here with energy using technology. What we're trying to achieve is changing social norms to a certain aspect, and that requires people to change their behaviors. And oftentimes change is something that's resisted, especially if it's not made easy for them. So we do, where we can, leverage technology, and today we're talking about BAS, as a way to make that change for people easier. But that in itself, you still need to make them aware of it occurring to make that change meaningful and have significant results from that. Behavioral science will point to things like self-efficacy, which is showing a user that they actually have an impact on what their actions are doing and that they have control over something. In the case of a BAS operator, they do have a lot of control, and if they can see that their control actually has measurable results, it usually results in positive behaviors. There's also cognitive dissonance, which is when people believe that they're doing something that's good, and then they find out not necessarily that it is having that same impact. And again, that can be something that we found through training. People can find that out through the way that they're running the BAS. And sometimes it's an epiphany for some operators where they're like, wow, I didn't know that the way that we had been running this system was incorrect, and it wasn't really achieving what I thought it was going to achieve. So keys to an effective BAS, it's knowledge of BAS capabilities, engaged facility staff, clearly defined roles and responsibilities, development of troubleshooting procedures, regular review of BAS analytics, and training and refresher courses even after there's been training done, and because there's turnover and things like that happening within these facilities. So you can't just say, oh, I trained staff on that facility 10 years ago, they should be good. At least at the region, we do have a little bit more cycles through staff than that. So I just want, as I conclude here, I just want to touch on what our approach to training is going to be. And it's similar to what Mississauga has highlighted. We've broken it up into levels of knowledge based on the different staff that is going to receive this training. Because we've heard from some staff that it's too complicated. We've heard from other staff, I already know all that. And we do want to have as wide of a breadth of staff to be involved in this as possible. We don't think that it's just an operator's concern. If we can get like your normal staff, the staff that aren't necessarily affected by BAS, but if they can be familiar of what it's doing, it can also help affect your complaints. So maybe at a manager level, if there's staff that are interested, we are inviting them as well. But they'd be more as part of the first module, which is introduction to BAS. So it's just general information of BAS, the benefits, and the role it plays in the built environment. So it's even kind of controlling expectations for people. It's not so that people understand that it's not some sort of magical thing that's going to make each office cubicle have its own temperature and things like that. It gives a little bit more information for those that are interested. The next step is BAS operator training. And these are tools and strategies for energy optimization and communication flow. It's kind of going through similar screenshots that we've seen there. It's for the property managers and BAS operators and specialists. I'm also encouraging project managers too, if they want to be part of that. I find, and I'm sure there's a number of project managers in this room, and it's the nature of your job that you have to just get the project done, and then what happens after that isn't necessarily your concern as much, depending on how your organization is set up. I think it is important that a PM is aware of some of the realities that the operator is then going to have to inherit. And that's something that we're looking to encourage within the region, so that when commissioning occurs, it's done a little better, because there has been cases at the region that the commissioning hasn't been great. There's been cases where it's been perfect. Usually the PMs that have the better commissioning often are more aware of the operating side of it too, and understand the value of commissioning in that process. And then there's advanced BAS operator training. Again, it's just taking it another step further and having them looking at the building analytics for detailed optimization. It's a next level. There's a few. These are more for the existing operators that are already quite engaged and are more thirsting for more knowledge. It's not. It wouldn't be necessarily something that staff are going to just jump right into. They probably work their way up. But there are a few facilities that have had BAS for a while, and they're ready to take the next step. And lastly is BAS specifications and standards. So this is just making sure that we're having the right equipment installed in the facilities based on that facility's needs. And even in some cases, if that facility even needs a BAS, there's some very small facilities that just because there's a spec and people think, oh, well, we're just going to put that in here, and it's like the need isn't there. You could get away with a smart thermostat and meet the requirements for that facility. So it's just educating staff to think that not one size fits all, and to work with the needs of a facility. So just to conclude, the region is working in partnership with Enbridge to develop these different training materials. So we, as I mentioned, we're going to be working through developing those individualized training sessions, and we're also going to be creating region appeal-centric BAS manuals for the different operator staff and project managers to refer to when they need it. And the intention is to keep those up to date. And lastly, I'd be remiss not to mention that we have gotten funding through Enbridge's Run It Right program, and I know that they're quite keen to continue giving out money to others, so you should look it up.
We love it.
Thank you.
Thanks, Jeremy. Well, we're good on our time here, so
Not bad.
we'll have some time for some sort of a panel of questions in a few minutes. I just wanted to, and actually, Lisa, you can get up here if you want to, because this is your program. I'm kind of a Johnny-come-lately in the program,
Yeah.
right? So,
No, that's all right.
but just wanted to show a few of the results. One thing I want to do before I just want to remind myself and remind you, on the table there's an evaluation. You were to receive that little evaluation
Oh, yeah.
sheet. We'd love to hear from you, right? Any presentation can always be improved. Please let us know how we did. And if you return that sheet to the person standing outside the door, they will give you a ticket for a
Free drink?
beverage, a free drink later. So,
An adult libation.
oh, is that what it is?
Sure.
Okay, good. So just to recap on everything here, the Run It Right program really does focus a lot on improvements in the automation of the building, what we call the controls. 60% by count of the measures are involved with that type of improvement. The results are pretty impressive, right? I just picked a couple of buildings here, right? And you can read down. So we got equipment scheduling of air handlers, equipment scheduling of tune control sequences on air handlers, air handling unit, damper valve operation improvements, so that's optimization of control, right? And out air quantity reduction, so optimizing the outside air ventilation rates. So those are all basically building automation related. That's every measure in one building delivering 11.4% savings. The evidence-based results, we see the graphs of gas consumption versus daily temperature, right? And we didn't change the scatter much, but we brought the slope of the line down, which means as it gets colder, we're using less gas than we were before.
Yeah.
That's something that's important to Enbridge,
It
right?
is.
It's to be able to see these results.
Yeah, we often work through, our business is gas distribution, but we're also mandated to reduce gas consumption through the Ontario Energy Board. And it's an important part of our business because it allows our customers to reduce their costs so they can work through, heating and cooling their buildings as they, that's important to us as a company to make sure that our customers can afford what what we're selling them.
Here's another example, right? So we've got appropriate supply reset schedule, so adjusting the supply water temperature reset schedule, lowering the heating set points in particular spaces, and then tune the control sequences on the boilers. And this is an interesting one because, in fact, in this case, you can actually see the impact of the you can actually see the impact of the reset controller, right, in moving a lot of the points from here down to here. So on those warm days when it's not so cold, you can start to see that. So again, these graphs can all be seen by an operator or anybody in that facility on a day-by-day basis through the EMIS, right?
Yeah.
So, I mean, these aren't just things that are in a report somewhere. These are things that can be very visible, and you can express it in different ways, but this is the way we chose to express it today.
Yeah.
Just on a similar note, I've seen property management companies deliver savings across a portfolio of 100 buildings, a 10% reduction, simply by feeding back to an operator that a building is above a targeted value on a daily basis for electricity consumption. You could do the same thing here. You could target your gas consumption on a daily basis and feed back a signal to an operator, red light, green light kind of thing. Are we on track or not? And if we're not, what's the procedure? What's the investigation in order to respond? Right? And we're talking about savings in the 5 to 10% range on the gas side, and we've seen exactly the same thing on the electricity side. This is feeding back information, having operators then that are knowledgeable of the systems, understand how to use their VAS to deploy against these situations, and getting energy alarms as opposed to maybe even just a temperature alarm.
Yeah. And reducing your greenhouse gas profile, right?
Direct correspondence,
Yeah.
right? Because if you draw that pie chart, your costs are maybe a lot on electricity, but your greenhouse gas emissions, if that's one of your goals, and for today many organizations' goals are to reduce that carbon contribution, that's going to be gas. That's what you're going to get it from, because the association right now, electricity, is relatively small in terms of the number of kilograms per kilowatt hour.
Yeah. Okay. Persistent
Yeah,
strategies?
the persistence. It's
Yeah.
all about making sure that what we do, what we start today, or whenever we started, it continues, right? So, Jeremy, you spoke about documentation. I mean, I saw some documentation. We were working with Mississauga as well. Ongoing training and coaching, right? So that was your last point, Jeremy, and your one, right? The monitor and tracking using the numbers. We've got to do this. This has not been done enough in the past. Enbridge is mandated to do it, and every building out there has the capacity to do this today, to guide ourselves forward using the numbers. Plan for ongoing commissioning and periodic setup. So, even through the run it right, maybe we don't do a full recommissioning exercise, but we've got some hot points. We've got some things that we know are going to change. We need to go back and bring those into our regular reviews on a regular basis. And finally, marketing the success. So when you have success, this comes back to what you said, Jeremy, making sure people are aware when they are doing the right things that they're actually having that impact, making sure that we continue to engage them and we raise that level of participation through marketing the success. We started off talking about people, we're going to finish off talking about people.
Yeah.
Lisa, do you want to add any words
Well,
to that?
just about the plan for ongoing commissioning, the shelf life or the persistence life of Run It Right is 5 years. That's what we're tracked at or measured against through the Ontario Energy Board. So even after 5 years, we would encourage people to participate again, to have that redone, and let our investigation agents come back out again and see how you're doing.
So it is an ongoing piece.
Yeah.
So what the price of energy efficiency once was said to me years ago, is eternal diligence.
Yeah.
Or vigilance.
Yeah, vigilance, yeah. So we're happy to take any questions